Okay. Okay, so now we're live on YouTube. Okay, it has been a while since we met, but I think Mr. Das here, he posted a question in the class, and I think this is good that people are still seeking help, and we're trying to help them to the best of our
Yes.
ability. Okay.
Yes, sir.
Okay. So can you see my desktop?
Yes, sir, I can see.
Okay. So let's go and look at the question.
Sir, your desktop is not visible.
Not visible actually. You're not
It's
able to see
not?
your desktop. Yeah.
It
Okay.
is not visible. It is the meeting menu is there.
Okay. Let me share. So, how about now?
Yeah. Now we can see. Now we can see.
Okay. So basically, this is your question. I'm happy that you actually, okay, these are new, okay. These are new files?
Yes, sir. This is a new file in the those XYZ NRC.
Okay. Okay.
But I am getting a flat line there. You can see the graph there also. I have put it there.
Okay, I will download this so we can look at it.
Yes,
But
sir.
let me show you what I think was not right in your previous simulation or
Okay,
input
sir.
file. Okay. So my understanding is you have a phase space file
Yes, sir.
above the JAWS or the MLCs,
Yeah.
right?
Right.
Okay. So when we go and look at your input file, this is your input file. And yes, we'll open a fixed data file. Okay. So this
Yeah.
is your
This is.
accelerator.
Yes, sir.
Okay. Now, the issue with your model is your phase space file starts somewhere here, the
Yeah.
input,
27 point
right?
something. Yeah.
Yes. The problem is when you go and look at your input, you find Z of the first component module is 0, and this is wrong. So essentially what's happening is that it's placing the phase space file is placing it here. It's not placing
Okay.
it above the component module. Okay?
Yeah.
So this has to be changed to this is 28. I mean, just above the phase space file.
Okay.
Sorry, above the component model. What I've done, I went and saw your MLCs, and this is at 29.
Yeah.
So I
It
said,
starts 29.
okay, let's go and put this, the Z, I'll put this at 28.9. 28.9.
Yes, sir.
The distance where the phase space file was scored, that is better.
Yeah.
But that information, I don't have it. So let's run it. So when you run, okay, let's execute. Okay. And let's use the beam DP.
Yeah.
And we go to the XY scatter. All. Okay. 0 to 10.
Let's know.
None. Let's okay.
Precise.
Precise. So this is yeah. So now you can see the particles.
Yes, sir.
This is at 7. Let me, why is this relative precise? Yeah, we should get this roughly at 10. I did it somewhere. Did I mess up something? Okay.
You can check the ZO settings, sir, once.
Oh, I did not save the input file. I changed it, but I did not save it. Okay.
Yeah.
So I think that's the problem. I did not save the file. So let's go and now open and XY scatter. And precise.
Yeah, it's working now.
Okay. Now it's good because now you see it at 5, right? And here it's at
Yes, sir.
5 at 5. So this is, so that's the problem you had. Okay.
Yes, sir. Yes, sir.
Okay. So what else? So I think I have. There are a few things also I saw about. Maybe it's appropriate to mention it to you. Is try to, fix the physics. Okay.
Okay, sir.
So here I would put this as exact. Okay.
Okay.
And spin effect on. Now, if you want to, for example, the bound Compton, this might not be necessary, but
Yeah.
I tend to actually use the, I try to use the physics, update the physics, use the latest physics, algorithms. But at least if you want to use the latest in terms of electron transport, make sure you have this as exact and spin effects on. Okay. So this is number one. My next question, I have another question for you.
Okay, sir.
Okay. Why do you have, so I can see you have a slab of air
Yes, sir.
here, and then you made another slab here, this with a different material of 5:1.
Okay. Yes, sir.
Why is that? Why?
Uh,
So why
actually,
you had to,
sir, since it was not giving that 5 by 5, so I was trying it randomly by doing, if I do something else, it might work. So I worked everywhere. So that's why, sir, I did this.
okay. So let me tell you a few things, just hints.
Yes, sir.
First, you don't need to have these two slabs. You can actually, even if you want to still want to have this layer of a 5:1 material with a smaller cutoff, maybe some people would say, look, I want a material here with a lower cutoff, so, I get more of these low energy electrons. Maybe, that's important. I don't
Yeah.
believe in this situation it is important, but anyway, that's up to you. But instead of putting slabs, when you put this slab, you can actually, number of slabs, you have defined it Mylar. So that's your exit window, I believe.
Yeah.
Okay. And then you have air. Why don't you put a third one? Why did you go and put another component module? Okay.
Okay,
Right?
sir.
You see my
Right,
point?
sir.
So here
Yeah,
you
yeah,
can
yeah.
put 3 and then you put the third layer. That would be, okay. So these are just my 2 comments.
Yes,
One
sir.
last thing, I would, sometimes, maybe at the beginning when you're doing your tweaking your model or checking your model, that's fine.
Yes, sir.
Usually, all of your work you will be doing it at 100 SSD, so you're getting a phase-space file at 100 SSD. But
Yes, sir.
after you do that, maybe it's better that you actually get a phase-space file, let's say at 55 centimeters here. The reason
Okay.
is if you have an SAD sort of setup,
Yes,
you
sir.
cannot use this phase-space file for
Okay.
simulation in SAD setup.
Okay, sir.
Okay, because then you need to have your
Yeah, yeah.
water phantom some here and so on. So you don't need to compile a new Linux. All what you need to do is go to your slab. We need to just reduce the thickness
Distance.
of this air slab. So
Yes.
here
Yes, sir.
you have it. Let's say you have it 46
Yeah.
centimeters. So if I want to record something at, let's say, 60 centimeters, so I'm going to put this to be at 6. Okay,
Yeah.
so I remove 6 centimeters, 40
Yeah.
centimeters. So when I do preview, then everything, it should now be at, oh, because of this one, this is at 100. That's the problem. Okay,
Yes, sir.
because this one is at distance. Okay,
Yes,
that's
sir.
the issue. So there, that's why I would suggest you repeat, just remove this, second slab in the component module, compile the Linux again,
Yes, sir.
and that's what I would suggest.
Yes, sir.
Okay.
Sir, I have one more question here.
Okay.
Sir,
Do
is
you
there
want us?
any way to?
First of all, do you want me to open this file?
Yes, sir. You can open it.
Okay. So
Sir, I have
okay,
one question
go
in
ahead.
the previous setup you were showing just now. Beam energy.
Okay. So let me copy it here. There's
Those XYZ energy.
this is a dose XYZ file,
Yes, sir.
or okay,
Yes,
it's
sir.
it's
Those,
a dose.
those.
Okay, dose XYZ. Okay. Let's. This is a dose XYZ. Okay.
Yes, sir. I have a question here in the beam energy, sir.
Bimanashi. Okay.
Yes, sir. Beam energy.
Okay. You want me to open the model?
Yes, sir.
Okay.
Precise. Yeah, that one.
Okay, I have this one. This is
Okay.
actually your file that I just modified a little bit some things. Okay, what do you want to ask about?
Sir, is there any way to match the divergence of the MLC with the JAWS? Because we can match the the divergence with the help of that coordinate system. Just
Yes.
go to that, sir. Paired bursts.
Yeah,
So
for the jaws.
yes, sir. There on the left side. Yes, sir.
Yeah.
Using this, we can set the divergence of the jaw.
Yes.
But sir, is there any other way to set the divergence of the MLCE?
No.
To sir,
Okay.
how do we make the gaps are there?
This MSC, the openings, you have these
Yes, sir.
openings, right?
Yes, sir.
So you modify these openings. You know where the
Yes, sir.
MLCs are. So I would
Yeah.
say, for example, the MLC, I will take middle of the MLC.
Yes, sir.
So it will be a minimum, maximum. So in between, this is around 32, right?
Yes, sir.
31.5 probably, 31.5.
Yeah.
So I would calculate. I would say, okay, I want,
Sir, do I have to use the similar triangle method here?
yes, this is exactly what you have to do. Because here you have to put the openings, right? So these are the
Yes,
least,
sir.
right? And these are minimum and the openings
Maximum.
here.
Yes,
Okay.
sir.
So that's what you need to do.
Okay. Similar triangle method here also.
Yeah, yeah. Because here, the way this looks like, you have this open. If I look at the beams
Preview.
and preview here, okay, this
It doesn't.
is this is the opening of the MLCs. This
Yes,
is
sir.
at minus. I'm trying to think why this is distance. Okay, let's open. Let's look at this again. Define leaf openings. Specify the minimum and maximum at the top of for the opening on each leaf groups here. Add a row to start a new group. When a new row is added, then next leaf in the order will automatically appear in the you must okay. So from leaf 1 up to leaf 1 minus 15 of origin of leaf length. Bilal, do you know anything about this? Because I haven't done, yeah, I'm not sure about
No, actually, I'm
MLCs.
sorry.
Yeah,
No, I didn't.
okay. Because I'm seeing here minus 15. I'm trying to read to understand what's going on with this file. Minus 15 and 15. These are the leaves. How many leaves do we have? We have
Sir, actually, the half width of the boundary is 30. So to make the MLC fully close, we have to put minus 15 and plus 15 there.
30 is here, right? So this is, you're
Yes,
saying,
sir.
look, this is for the compound model. Okay, the half width is 30, right?
Yes, sir. Yes, sir. To fully close it, we
My
have to put
question is,
minus 15 and 15.
but I don't get it. Why 15?
Because the full length is 30.
No, 30
To
is for
make it,
this boundary.
yes,
This
sir.
has nothing to do with the MLCs.
No, sir. See the x-axis.
Yes?
It is also 30. That means the leaf opening side is 30, sir.
I don't get it. I don't understand this.
You can
Okay, because
change the value there.
this is the leaf, right? This is the leaf.
Yes, sir.
Agree? Okay. So we're saying what's minimum and maximum? To me, it looks like okay. Let's try to look at the help to understand what's going on. Okay. Okay. This is uh,
Round MLC,
okay.
left
These
one,
are the
sir.
openings. Left one, right? I'm just trying to
Yes,
see
sir.
the R max position. Yeah, I'm not sure. I really don't get it.
Yes, sir.
Okay, this opening. I don't understand minus 15 and y 15. Is
Okay,
this
sir.
this is the leaf is going from minus 15 to 15, and maybe I don't have maybe okay
Either it
because the
should be from 0 to minus 15 or 0 to 15.
well maybe look I have a problem with the resolution. Okay, resolution is a bit
So
bad.
to look it fully, you have to only rotate the window because when I put all these values, I rotate it portrait mode, the laptop screen. The full screen doesn't come, sir.
Okay, it doesn't come. Okay,
Yeah.
Yeah, you have to
I'm trying to
portrait the
think
whole
of
window.
these. What do they mean? Yeah, how many MLCs do we have?
40, 40, 40 leaves pair.
Oh, 40 leaves. 40 from each side? From each
Yes,
side.
sir. Yeah.
It's 40 pairs?
Yes, sir.
Okay.
Portrait.
Yeah. Let me try to see. Okay, I cannot do the portrait. I cannot do it, but I will look into this. Okay, see changes.
Okay, okay, sir. Sir, your
Okay,
display is not visible.
I cannot do portrait for some people.
Okay, sir.
Yeah, I'm not sharing it. Okay, I'm trying to look at another thing. Okay, okay. Let's see if I have it in. Okay, what else do you have? You had a dose XYZ file, right?
Yes, sir. In the dose XYZ file, sir, uh, I want to see the beam profiles and the PDDs from the same file you have just created, face space file from beam
Okay.
energy as a shared library. That is source number 9 there.
Okay. Okay, I don't have the precise Linux here. Okay. Okay, I will look into this MLCs and probably, reply back to you on our group. Okay.
Yes, sir. Yes, sir.
But the opening looks fine. The opening looks okay to me, to tell you the truth. When I look at the top view, it seems it's open. So these are the MLCs. MLCs. So the top view, I mean, it looks like they're open, but like a small field here. But how we get to define this, it's not clear to me how we
Yes, sir.
do that. There is something in defining, but I'm not sure why it's minus 15 to 15. What does this represent? Because this is leaf number one, minus 15 to 15. It's the width of the length of the leaf. Do we have 40 on each side? I really don't get it. I don't understand this. Okay. So I'm going to look into it
Yes,
and then I can reply to you. Okay, let's look at the
yes, sir.
dose XYZ.
Yes, sir.
Okay. Dose XYZ. Okay. File,
So desktop is not visible.
desktop. Okay.
It's not visible. Yeah, now it is visible.
So let's go and load the previous input file. This is the file, right?
Yes, sir.
So what's the issue with the file? Let's check it and see what's going on. Okay, first of all, when you use a phase space file, try to use all. Okay, that's number one, because
Okay,
you
sir.
want to actually include the electrons in your phase space file. So that's now. Let's look at the
Yeah.
pattern. We have three groups: minus 15, 1 up to 5, and then 0.2. Okay, so you want to find a resolution. and here is
Yeah.
probably the same. Yes, and then here you're going with okay. Why here minus 10?
Uh, because I want the dose at the center of that at 10 centimeter depth.
Yeah, but this is the boundary. So why are you putting minus 10? You're defining the dimensions of your phantom from where it starts and where it goes to. So why are you
Yes, sir.
putting here minus 10?
Okay, okay. It should be zero, sir.
Okay, so this should be 0.
Yeah, it should be zero.
Okay, and fine, you want this minus 2. So maximum value, this is 30 centimeters. Okay, fine. Number of media, I would go and select 2 media, not 1.
Okay,
You will understand now. I will take this and I will take air. Okay, and
okay.
media voxels. Okay, you did not define here anything of media
Yes,
voxels.
sir. Yeah,
Nothing defined.
nothing defined, sir.
Okay, maybe that's the problem.
Okay.
You need to, so here we have 5, 10, 5 and 100, we have 110. Here is 110, and here we have
Yeah,
110. So you have 110 voxels in all dimensions, right? In all
yeah,
directions.
yeah.
So here we need to add a group. We say, okay, from 1 up to 110, 1 up to 110,
110,
1 up to 110. We want to
110.
put water there.
Water.
Okay, density. If you want to override the density of water in the PEX data file, you can do it here.
Yeah.
But we wanted to use the density in the file, so we leave this. Okay,
Okay.
that's fine. So we are okay now. So let's go and look at your here. Yes. So thickness of region outside phantom, we can make it
Yeah.
uniform, and let's take a 30 centimeter thickness outside of whatever phantom I have defined, and I want to put that to be F.
Okay.
Okay.
But so
Okay.
that
So
AR
that's
option was
material.
not coming.
What's that?
The AR option you have changed right
Because
now. It
because
was not
here,
coming.
yeah, because I defined it, right? You had initially one media, and you only selected
Okay, okay.
water. So I put 2, and I selected air. Okay.
Okay, sir.
And I use that
Yeah.
air here. Okay.
Yeah, sir. Yeah, that's right.
Okay. Yeah. Output restart data. We want this at end of run only. Okay.
Okay.
You had never. So if you run something, you cannot restart it. Okay. So we want it at the end. Okay.
Okay.
Uh, uh, but default sometimes when at every batch. But this basically, especially if you're using parallel processing, and especially like the case with Bilal and myself, where we mount through the network.
Yeah.
This means that especially if your data file is huge, then writing, the results of the simulation after every batch is going to, slow down your simulation. So the
Yeah.
best thing is don't do it. You don't do it after every batch, but leave it at the end. When it finishes running full simulation, then go and write the results to a file. That's it.
Yes, sir.
Okay. Let's check the physics. Again, you're not checking the physics, but that's the least of your problem now. Okay. So here you can modify things if you want to use cloud, prompt, and all. Okay.
Yes, sir. So that
So
source
don't
type.
forget to, yeah. So now the source, we're going to go and check the source.
Yeah.
So let's go, and your source looks correct to me. Okay. It
Yes,
is
sir.
correct. Okay.
Sir, in this simulation, I used
Uh,
the earlier phase space as a library.
Lina. Okay. So it's correct what you're doing. So you're doing treatment head simulation. This is, you have compiled it as a library, the beam
Yes, sir.
compiled as
Yeah.
a library. There it is. And this is the input file. I'm going to change this
Yeah.
to this input file because I have done it.
Yes,
Okay,
sir.
okay. Because you had some problems with your input file there. So
Yes, sir.
there, and this there, and then when we run this, so now it should be okay. Now there is something you could do if you want. You know, sometimes people can speed up the simulation if your material is fully water. If your
Yeah.
fountain is fully, I mean, you don't have heterogeneities, maybe
Effortless.
you can turn this to be on. Yeah, on. I usually don't turn it on. I put it off. So the simulation is a bit slower, but that's fine.
Yes, sir.
Okay. So a number of times to decide, okay, this one, you don't need this, it's irrelevant because now we're using a different head simulation. And now when I run the simulation, so let's
Same.
save the input file and let's run the simulation. One thing of job has finished. Okay, 5 to 1 because following lanes were not recognized. Okay, well, I had edit parameters. Okay, let me check how the text data file is not perfect. Yeah, phantoms. Okay. Mhm. Okay, and this edit. I want to check here again.
Uh,
Okay.
so,
I know what's the problem. I know the problem. This is something related to my file. Okay.
yes, sir.
Because I'm using an older version of the Linux, and
Okay.
then I realized that water, I instead of putting H2O, I put H20 in the name. So that's why everything is that's why it's complaining that it's. Don't worry about this. Probably you have it correct. So run. Job has failed again. Okay, let's go and check what's going on. File. Where is the error? Did I say? Okay. Error.
Atomic relaxation, please
Please
turn
turn
on.
on. Oh, okay, here. Please turn on atomic relaxation. Okay. We will go and do this. Go to the physics. And yes, atomic relaxation, we operate as on. So let's, because I turned on bound constant. Save input. Run. Okay.
Yeah.
One
Okay.
way to check that everything is okay, I will show you something. At the end of the simulation, it's going to output what's the fraction of energy deposited in the fan. So in your case,
Yeah.
probably it was 0. That means nothing was deposited. Okay. So I
Yes,
can
sir.
immediately
So you
check
saw
here
the
without,
graph?
okay. So here, you see here, no, this is the problem. You see, I immediately saw I have a problem here because the
Yeah. Yeah.
fraction of incident energy on the phantom is 0. Okay.
Yeah.
Uh, so I know there is a problem. Now, why is there a problem? Or,
I also
or
received the same problem actually. I was just simulating the Clinac. It was showing the same zero. Deposited energy was zero.
yes, because there is a problem. Parallel. Okay. Okay. I have a simulation. It runs, by the way. I was doing it today.
Yeah.
So if I go and check your modified file, this is
Yeah.
the file I've done. Okay. And this one works. I know it works because I could get something out of it. But Why in your case, what's wrong? And I use the same thing. So here it has simulation 00180. It's the beam simulation model. This is my input file and the text data Lena air uniform 30. My phantom definition is a bit different. Okay, let me go and open your file again.
Okay, sir.
I like to do, so that we understand what was the problem. So there it is. Okay, let's go and change define media. Fine, I select maybe in this. Oh, here. Okay, this is vacuum. I have to put this water. Okay.
Okay, sir.
So because I had something wrong in the naming, maybe it defaulted to vacuum. So
Yeah.
now let's save, and probably I would just do 1,000.
Yeah.
Run. Okay, here this now it's not zero. You see this?
Yeah.
The fraction of, okay, now it's not zero. So now we should get something. If we use
Yeah.
stat those, we can so the read 11, okay, 1 and 0. Read, okay, now do 5 plot profiles. 1, let's look at the PVD. Okay, nothing is there because probably I don't have enough particles. No, not enough simulations there. Let's accumulate more. Because I'm sure there is something deposited, some dose deposit because the fraction is no longer zero.
Yeah.
With 1,000 particles, none was deposited in the central axis. So that's why I'm getting a zero there.
Yes, sir.
Okay. Okay. So let's try this again. And we're going to read. So it's 11.
Plot.
And then we go back. So 5 top. Okay. Again, nothing is there. I'm surprised.
Yes, sir. This
Let's
is the
look
issue I
at
was facing.
statistics. Statistics. Let's go and look at the read dose distribution. Statistics. Oh, I did not read anything. I thought I did 11, 8, and 1. Okay. Statistical analysis. Please read in more data. Okay, normalization. You know why? I think because this is read dose distribution. I was doing this one. 12 is exactly your linear.
Yeah.
Okay. How can I plot? I think we just need to have more runs because this is the PDD I'm getting. So we
Okay.
just I think we need to Emacs.
Have more histories.
I will run it in parallel processing. Okay, so I can get more uh,
Yeah.
particles. Okay. Do you do parallel processing?
Yes, sir. Right now I'm doing, sir. I learned from you.
Okay. Okay. So let's do 1 million.
Okay.
Okay. This is why we have here. Why this is one? What is this one? I'm not sure. This is zero. You should have this to be zero. So 002. But why do we have one? Oh, one is the type of particles, right?
Yeah.
One. Yeah. So let's go and I think this is two. Then it has to be two. Let's go and check again. Edit parameters.
Oh,
Particle. Right. So it has to be two. Oh, execute. It's restarting. I don't want to restart. Yeah, there is for sure there is something deposit, but I'm not. I'm worried because especially we're doing smaller, small resolution.
yeah.
That's why we're not seeing something in the center. So I would put here million. Okay, EXP. Voice. Okay. So how is it going with you, Bilal? Any progress? Any projects?
I have some actually few questions to be raised regarding the clusters.
Okay. Okay. I'm helping someone to model a total skin
Okay.
electron beam. I learned a few things, few things actually. So I now know how to, for example, tilt the gantry in the simulation with different weights and so on. Very
Anything
interesting.
actually, anything kind of regarding the brachytherapy?
Bracket, bracket has to be done through X++. Okay, or you write a code. You write your code. These user codes that we're using, whether it's Beam, those X, Y, Z, and so on, these are ready-made codes. The geometries
Mm.
are, you know,
Yeah, I understand.
yeah, yeah.
They have
So
fixed mode of only we
fixed,
can't
yes,
modify that.
yes. Okay. So then you need to create your code, define your geometry, define these things. And with X++, I think that is doable because they do have some simplify things a lot.
Any idea
Unfortunately,
actually the EGS is coming out with a new version of this year?
I don't know.
Because actually I have been seeing in the network that they are doing some modifications regarding the batch also. In fact, the for clustering also they are doing something.
Yeah, probably that's. I
If
mean,
they
that's
could add the brachio also as a main program, then it will be better. Then
yeah, or at least if someone can come up with a interface, a graphical user interface to make things a bit easier, how to
okay,
for X++,
yeah.
then okay, still I don't see anything. Okay, where
Yeah.
is our beam then? Where is our beam? Okay, I'm gonna do another trick. Let's review those XYZ. Okay, those XYZ show. And let's do this. So nothing is actually deposited there. What's going on? I really don't know what's going on. But I know I made a file that works. My file works.
Okay, sir.
So
So that
I'm trying to get what's going on here at the end of the run. So this is the head simulation. Input file. Yeah, it looks to me it looks okay. We
Something to
have
do with the
this.
phantom. Maybe the phantom is actually.
I'll check again the file.
so that XYZ 000, is it okay, sir?
Z XYZ.
000 in that
Yeah,
beam treatment head simulation.
yes, I think so. Because this goes from minus 15. We find the Z. Okay. So 1 up to 100, define the median. I'm going to check this again. Unless there's something wrong in my in this median. Maybe there is something wrong. Okay. Let's try something else. Okay. Because I'm using an older version of my snapshot. Uh, but what we can do is change the text data file, and let's use the one that they have 5 to 1 ICRU.
Yeah.
Okay. And let's edit the parameters. Okay. Just need to change and define two medium. So this one is water H2O. H2O here. Okay, and this one,
Yeah.
I think we have, we'll use A5 to 1. Oops, define medium. And here it's H2O. Fine, everything looks okay. Select the oxys. Okay, here we're gonna
So
put
in the
this.
source type, that 000 is okay.
Yeah, because your phase space is,
XYZ 00.
this is your phase space. You're collecting it.
Yeah.
This is your isocenter. You're collecting it at 100, right?
Yes, sir. Yes, sir.
All what you need to do is to have a theta 180 so that it's shooting down. So yeah,
Yeah.
you have it here, 180. This is, to me, it looks correct. I don't see a problem there. Okay, okay, we'll give it a shot. Save, and let's try. So check, I might have something wrong in the fixed data file. That might be the issue.
Yeah.
So we're gonna check now. Okay, 0.5. Okay, I have a problem. There is something I don't get. Yeah, I really don't know what's going on. But let me show you what I have done.
Yeah.
Maybe that's why. Okay. Oh, there is a 3D dose. Let's see something now. Okay. There is
Yeah,
this 3D dose file. And do I get a 3D dose? Yeah, there is a 3D dose file. I really don't know. But I can share this input file with you and also the
yes,
input
sir.
file for the Linux. I can give both of them to you.
Yes, sir. Kindly
It's
share
probably
this.
one setting. It's probably one setting that I messed up somewhere. Uh, but it should work.
Yes, sir.
Okay, you saw now there is a dose and looks fine. A dose distribution. Uh, this is
Yeah.
okay. So there it is. Okay.
So we can directly compare this with the RFA measured data.
No, yes, you can. So, but what you need to do is to use the stat dose. So get the stat dose, read it, and for example, I can debin it or normalize. Let's
Yeah.
normalize to maximum dose. Okay, P, and then 0, and then we can plot profiles. 1, 2,
Yeah.
so this is, of course, I need more statistics,
Yeah.
more simulations,
Yeah.
but this is essentially this is the PDD, and
Yes.
the profile you will have it. The phantom you have generated is actually better than mine in terms of profile and
Resolution.
resolution. It is better, so use that
Yeah.
uh, for for PDD and profiles you know. So here, if I do this, then this is 0, 1.5. This is the profile at D max. I get something like that. Okay. So it's a 5 by, 10 by 10. Looks like a 10 by 10.
Okay, sir.
Okay.
Yeah.
Okay. Any other questions from your side? Yeah. Any other questions or from
No, sir.
Gas? Okay.
Yes. No, sir. I don't have any further questions. Sir, you kindly share those files
Yeah,
over
I
the
will post.
classroom.
I will post them in the classroom.
Yes,
Okay,
sir.
and then you can.
And
So one thing also. Try rename your input files and so on. In a way that you can know immediately what is that file about. So having
okay, sir.
a file called precise, okay, is that for a 10 MV? Is it for a 6 MV? Is it for, let's say, a simulation at 100 SSD? What was the field size? So
Yes,
try
sir.
to keep this information in the file name. It's
Yeah.
better, okay?
Yes,
At the
sir.
beginning, yes, but once you have to, really make info information in the file name, that my suggestion is better.
Yes, sir.
Okay?
Yes, sir.
Okay, Bilal, what's going on?
Oh, yeah. My cluster is working, but I have some actually issues with the cluster actually. So that is nothing to do with this EGS.
Okay,
But
so I'm
the
going to
problem is
stop
now,
this. I'm going to
yeah,
open now my cluster. Okay.
yeah,
Okay, let me share that. Okay, you see now my desktop, this is my
yeah,
cluster.
yes. Okay. Okay.
Okay.
Okay, good, good.
So what's the question?
The question is now actually I find sometimes actually that it suddenly stops. The SSH is not taking place. I'm not
Yeah,
able to SSH into the systems. Do you face the same problem? Actually, I just wanted to ask that.
SSH?
Now, do you keep the cluster on continuously?
Yes.
Even otherwise, also normally, if you don't have any even simulations.
Well, yes. Raspberry Pi, I keep them because sometimes if I don't, then I have to go and restart the Slurm cluster.
Okay.
Okay,
Okay.
with the command.
Because what I faced was actually sometimes, suppose for example, I switch it off for a week, then I switch it on again. I find they are not synchronizing, and the SSH is not happening. I'm not able to
SSH.
SSH. Oh yes,
So do you usually SSH to one machine or to
one
all of
machine.
them?
Yeah.
Okay.
Actually,
Open S.
I do it for other machines also. But first of all, the main cluster, main node, I want to SSH, but it rejects the connection.
Okay.
So that's what I
It re,
want to
it,
know
re,
that.
it rejects the connection.
Yes, it rejects the
And how
connection.
and how do you fix it?
Now what I do is now then I have to go into the system. I have to put a monitor, connect this monitor. Then I have
Yeah.
to restart the system, restart the SSH.
Okay. Do you use keys, host
What?
keys?
Host key I use it. It connects actually. Many times it connects automatically. Host key also. But
So
sometimes it
does it?
happens that it does not reject. Then every time I do it again after that, it rejects every time.
Okay. Is SSH the server? Is it enabled?
It is enabled, but when it's not rejecting it, it gets disabled. I have to go to the system again separately. I have to restart the service.
Yeah, but my question, is it enabled? So when you start the computer, does it come on automatically?
Yeah, it's come on automatically. It comes on.
Hmm. I'm surprised.
I just thought actually a strange behavior actually I faced it. Sometimes it happens. But what happens normally is I switch it off. If I don't have any work, I switch it off for a few days. Maybe I can switch it on. It happened. That may be the reason.
No, but that's should be okay. So
In
uh,
fact, once I installed the OpenSSH again. Also, I removed it. I installed it again. But I face the same problem.
uh,
But not every
see.
time. Every time, not every time. If I keep it
Yeah,
on, then okay, no problem. But if I switch it off and again switch it on, I have to manually restart the service.
yeah.
The second question is actually, do you have a SSD, isn't it?
Let's say this status. So when you issue this command, do you see here enabled?
Yeah, it is. No, when it rejects it, then that time it is disabled.
No, enabled. No, enabled.
It is
Enabled.
enabled. It is enabled
Okay, enable because enabled means that okay, when you start the computer, it should start it automatically.
automatically. Yeah,
Enabled
but at
doesn't
the
it doesn't mean that it is on.
no, but
Okay.
at the active at the lower point, the active there is active is there. No, at that point, it is not active.
Yeah, this is fine. This is fine. This is fine. But here, enabled is
Yes,
that
it is enabled. Yeah, it is enabled.
okay? Because enabled means that when you turn on the machine,
Yeah.
it should boot it up, should
Oh
bring
yes,
it up.
yes, yes.
Okay.
It is
So
coming.
if it's not
It's
enabled,
okay. Yeah.
okay. So enabled. So what I would suggest: keep the monitor in, turn
Okay.
off the system, turn it back on,
Okay.
okay, and
Okay.
issue SSH. Look at system CTL and see what's
Okay.
the status,
What is the
okay,
status
of
of that?
this.
Okay. Status.
Okay, see, this is probably this would be, but look at here.
Okay.
Do you see word enabled or not? If the word enabled is not there, then all what you need to do is here you put enabled.
Restart the internet.
Okay, enable means whenever the system starts, start this service.
It should automatically come up.
Yes. Okay. This has nothing to do with active or not active. That's something this different. Okay, so basically it puts it in somewhere that okay, when the system boots, start the service automatically.
Okay.
So check that.
Okay. I'll do that.
Okay,
And the second one is now,
okay.
do you have a SSD in your system?
I have an SSD. Yes,
But
in
do you
the
work with the
Raspberry Pi,
SSD?
right?
Okay, yeah. I actually what I found was that with the SSD, the system starts very slowly.
With
It's
SSD
lagging.
drive.
With the SSD connected, when you restart again the system, it boots very slowly, very slowly
Uh,
compared with the SD card.
okay, so you boot directly from the SSD,
SSD,
right?
yes, yeah, yes.
I'm surprised because mine looks okay.
I had a SD card earlier, then I shifted to SSD now. Now I'm having SSD only, but I found there's a lot of time lag actually because when with the SSD it takes very long time. Once it boots up, it's okay, performance okay, but when it boots up, it takes a long time to boot up.
Okay. Uh, it has external power.
For SSD,
Yes.
no, not
So
external
so
power.
okay.
USB, it's USB
Uh,
powered, no?
but maybe the Raspberry Pi itself cannot power that. I will show you what I
Okay,
have.
okay. The load, maybe the actually power output may be actually low.
Yes. So maybe check
But the power
if
consumption of SSD will be very low compared to hard disk.
okay. Okay. So that's okay. So this is
Okay,
okay.
good.
This is something old. I need to bring. I need to. Okay.
Some new
Yeah.
construction you have something.
No, but this is an old one. This is a Raspberry Pi 3.
Okay, it is Pi
Okay.
3 that one.
This is
Okay.
this is a Raspberry Pi 4.
Okay.
Okay. And you can see here. This is the
Okay, got it.
hard disk. It's a 1 TB,
This is a hard disk,
right?
not
But
SSD.
it has its own. It has yes, yeah. And you see, I don't have if here. Where is it? Yeah, here.
Yeah. Yes.
This is where I should have the
Okay.
I boot from the drive.
Okay.
But
Okay.
you see, it has a the system has some external
Power
power.
supply. Power
You
supply.
cannot.
Okay.
I don't think yes. So what's happening? This power, external power. It's powering up. I have a board, and then from that board, I take something power to
Okay.
power the Raspberry Pi.
Okay.
Okay, the Raspberry Pi, whatever this spins the power, I don't think these are capable to power
Of driving the cake. Okay.
the SSD or the power from the USBs. I think this is too low.
Okay. 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 I understand now. I understand.
Okay, yeah, so that might be the reason.
Okay. Okay. I understand. I understand this.
Okay, yeah, but these are these are the big monsters. We have them.
Okay, I can see that now. Actually, I'm very happy to see all those things. Okay, I don't in fact, I added a fan, not this fan. I added another fan just
Yeah,
recently. Only I added a fan. Okay, I
yeah,
had 12 dual fan connected together now. I added that now.
yeah, yeah,
I keep adding actually. Now
yeah.
I have
This
four,
is,
five nodes now.
and here at the back, I, yeah, these are my over E switches.
Actually, one
Okay,
problem I am facing here is in India. I think I'm not getting I'm getting a PoE switch, but I'm not getting that PoE hat for connecting to the Raspberry.
but that you have to buy.
No, I know, but it's not available anywhere actually. Not in Indian shops. Not everywhere available.
Amazon, can't you buy from Amazon to be shipped?
No, but Type C, we need a Type C output. No,
No, this is it's no,
no. But
because
from the
you're
POE
talking
switch,
about
I need a Type C output.
no, from the switch, it's everything is going through the Ethernet. This is why you
No,
need the hat, right?
we need to put a hat. Okay, that's what we need to put a hat.
Yeah, this is the
Okay,
switch. Okay,
okay.
this is
You
even
have put a hat.
powerful
You have
than
put a hat then.
yeah, but this has a fan inside and it's very noisy. So
Okay.
I decided to take it off and use
You put
two
a hat
small.
for every. You put a hat in everyone. Every. So,
Yeah, I have a hat.
okay, okay.
Okay, so the hat is here. Okay, this is okay. Let me
I
try
don't
to
find
put.
that. Okay, it's a hat. Sir.
Okay. So this is the hat. This is it.
Okay. Okay,
Okay.
that's okay. Okay.
So I put it, and once you have the hat,
Okay.
uh, yeah, this is maybe here it's visible. So this is a hat. It goes. Uh, it's like a small U shape.
Oh, small board, small PCB board, no?
Yeah. So you put it over those pins. Okay.
Okay.
And then you see, I get the power from the
Okay.
Ethernet. Okay,
Okay.
and
Okay.
here
Okay.
and this is now it's the
It's
yellow.
supplying both internet as well as the power
Yes.
supply.
So yeah. So this the yellow light when it's out, that means there's power also from the
Okay.
line.
Okay. 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 I
Okay.
think I have to establish both
I think
actually
this
then.
is I think this is the power and this is no I think no, vice versa. This is the Ethernet and that's the power. Something like that.
Okay. Okay.
Okay.
You have a very
So
good
you
cluster
will
now.
need okay. I have a hat. There are several types of hats.
Oh, actually, I saw in the network. Yeah, Amazon also. I saw there are several type of hats available.
Yeah, just make sure because I got a hat that that hat is not compatible with the. Actually, it is. Okay, let me show you another hat. This is another hat. Okay, so you see,
Okay. Yeah.
this
It
is
had a fan with the fan.
this
Okay.
has a fan. Okay,
Okay.
I decided to take this out. I did not want it because
Again, to draw power from the pins.
well, this is a you see this is it. Okay, so what you do is on the Raspberry Pi,
Place
you're going
above
to
the
put this. These these will be on the pins.
GPR pins. Yeah.
Yes. Now this is I'm getting power, and the power is supplying the fan.
Okay.
Okay,
Okay.
so it's built in.
This is compatible with the Raspberry Pi 4.
Yes.
Okay. What is the
Okay,
model? What is the name of the actually this one? Can you tell?
but I don't like this one. Well,
Okay.
unless if you want to have the hat. Sorry, if you want to have a fan with it, the fan is a little bit noisy.
No, no need for a fan. I think no. We can have put an
Yeah,
external fan. We have already.
yeah. So this is not what I want. This is so I after I bought this one, I
Hmm.
decided, look, this not I'm not going to buy it anymore, and
Okay.
I went
Okay.
for the other type. The other type it
Which is
looks like a U shape or something like this. I can open now the net and show it to you.
okay. Okay. Now that's why if you, I can you can suggest me something, so I will buy that also.
Yeah, let me try to find something for you on the net. Uh, okay. I will close the YouTube, okay? Because this
Yeah. Please.
now.
Yeah. No, yes. Yes. Yes.
Okay. Okay. By the way, do you find these small videos that I'm making how to do this and that? You find them
Yes. Yes.
useful?
Actually I saw the two videos you all uploaded it. I saw both.
Yeah. I
They are very
wanted to
good
make
actually. In
it.
fact, I wanted to say it's very good because many people you must be knowing there is a Reddit community for EGSnrc.
Yes, maybe, but I'm not a
There is a
member of
Reddit
that.
actually. A Reddit community is there for
Yes,
EGSnrc.
true,
Yes.
true. Yeah. Yeah.
They have been
So
asking so many questions. In fact,
yeah.
I suggested your videos also there.
Okay, I'm gonna try to now when I have time, because editing the videos takes a bit of time.
Because
So
actually, I'm sorry to say that, but what I we found was that your voice was very low in all the videos.
okay, so I should make it louder,
Yeah,
increase.
please, actually, that will be better.
Okay, yeah, no,
It
it's
will be
good.
a